Okay, so we've talked about central angles. Today we're going to talk about inscribed angles. So let me just show you what we're talking about. So a central angle comes from the center and intercepts an arc. So something like that. And what do we know about the measure of this central angle in comparison to the measure of the intercepted arc? Yeah, they have the same measure, don't they? Okay. And again, this is another weird thing. This angle and this arc have the same measure. But are they congruent? No, they're not the same thing. This one's an angle and this one's an arc. So again, there's two things again that are same measure, not congruent. Okay? So anyway, today we're going to talk about an inscribed angle, which would be something like this. Comes to here, and then it comes to there. So this would be an inscribed angle. Notice that I have it intercepting the same arc over here. Okay? And I just want you to look at it for a second, and if this is circle P, so that's angle P right there, and this is point A over here. This is B and this is C, so that's arc BC. What do you think about angle P in comparison to angle A? Do you think they have the same measure? Do they look like they have the same measure? Look carefully. Here. This one appears to be slightly over 60 degrees. 63, 64 degrees, something like that. Okay? Let's come over here on angle P. Any guesses what it might be? 20 something? 30 something? Oh, about 32? Okay, so about 32. This one, it looks like it was about 64? This one looks to be about 32? Okay. Now your brains have had a time to digest that for a second. What do you think about inscribed angles in comparison to to central angles? And it's half. So it's half the intercepted arc rather than the same as the intercepted arc. And let me show you a few things here. If I put a different point over here, point D, and it intercepts that same arc, what's going to be the measure of angle D? Yeah, it's still going to be 32 degrees. If I have a different point up here, way the heck up there like that. See how that angle right there intercepts the same arc? What's its measure then? 32 degrees. Why is it half? Yeah, I suppose if we just look at some arc here, right? Okay, so here's an arc. If I start up here close, we can see that that's a fairly large angle, isn't it? Close to 180, right? If I get a little further away, what happens to this angle right here? Yeah, it gets smaller. And if I get further away, it gets smaller again, doesn't it? So when we look at an inscribed angle, now talking about why it's exactly half, that's an interesting question, which I'm not really sure I can answer completely for you, but we're gonna take a look. So if we have our inscribed angle, or our central angle here, right, and then we have an inscribed angle back here, so you know, I kind of made these. Can you guys see that? I don't know. So it kind of makes sense. You can see whatever this one is, this is half of it. What may be a little bit weird though is when I came over here and I intersect. Okay, there's another inscribed angle, intercepts the same arc. These two are going to have the same measure, aren't they? Well, this one actually looks a little, it looks pretty close, doesn't it? So it's not, we are doubling the distance here, which would make sense. So we got 1 radius, 2 radius. So we're twice as far away. Okay, it's half as big an angle. But then when we look at this one, that one's not twice as far away, is it? You know, if we come over here, I remember when I was taught this, I think my professor just said, well look, the inscribed angle is 2 radii away, it's 2 radiuses away, so if it's double away, then it's got to have half the angle measure. But then I'm like, I can remember thinking at the time, well, what about that one? It's not twice as far away, is it? But can you guys, just looking at it, do those all 3 look like they have the same measure? They do, don't they? We could put our, what's this thing called? Protractor on here, and we can measure them, and they're going to have the same measure. That one's 35 degrees. That one, yeah, 35 degrees. Come over here, 35 degrees. So that's a little bit of an interesting question, and we'll get to it. So if we can remember that it's half, let's see if we could do some problems with that. Turn over to page 554, will you? I think you're all there. Bottom of the page, example 1. Any guesses on arc TQ? Say it loud. 25 degrees, isn't it? The measure of arc TQ is 25 degrees. It's half the inscribed angle, is that correct? There you go. It's 100 degrees, isn't it? How often do you think we do that? We're like, oh, it's half, and then we see the angle, then you half it to get the arc. So what do you have to do? If you have the angle, what do you have to do to get the arc? Double it. Okay. So arc TQ must be 100 degrees, right? Okay, what about angle RTS? 24, right? It's 24 degrees. Go over to example 2 now. I want you all to tell me about angle STR. 31 degrees. How can that be? How'd you get there? Kimball, say it. You tell me. Say it loud.
They intersect the same arc.
Yeah, they intersect the same arc. So it intersects the same arc as angle SUR, doesn't it? So if they intercept the same arc, they've got to have the same measure. That makes sense to everybody? I see a lot of head shaking. Awesome. Okay. So this is the inscribed angles of a circle theorem. Pretty simple. If two inscribed angles of a circle intercept the same arc, then they're congruent. So that's easy enough. Okay, turn over the page and we got a couple more. Okay. Let's talk about an inscribed polygon. A polygon is an inscribed polygon if all of the vertices of the polygon are on the circle. All of them are on the circle. And most of the time, we're going to be looking at quadrilaterals. Some type of quadrilateral that is inscribed. It doesn't have to be any type of regular shape. Something like that. So this would be an inscribed quadrilateral. What do the three angles in a quadrilateral add up to? What is that? 360? 360 degrees. And so these four angles add up to 360 degrees. The number of sides, subtract 2 times 180. Okay. And, okay. So all four of these angles, angle 1, angle 2, angle 3, angle 4, they add up to 360 degrees. But aren't they each half of the intercepted arc? So doesn't it seem like they should add up to 180 degrees? Because how many degrees all the way around the circle? Come on, you can do this part. How many? 360. So if it's 360 degrees all the way around the circle, wouldn't it make sense that all these angles would be half of that, since all the inscribed angles, aren't they half of that arc? Each of the inscribed angles is half of the intercepted arc, isn't it? So why don't they add up to 180?
Because the arcs intersect each other.
Say it louder.
They like cross over each other, like or the arc, or it goes over.
So if we look at angle 2 right here, it intercepts this arc. Here, let me try that again. It intercepts this arc, doesn't it? Okay. Well, angle 3 intersects that arc, doesn't it? So see how they both intercept this arc, this piece? Okay. So when you look at how much of the circle these angles intersect, they actually overlap each piece once, and so you end up with 720 degrees. And then what's half of 720? 360, and then that's their sum. So I just wanted to, I didn't want you freaking out about that a little bit. So you thought the quadrilateral was what?
You can't have a quadrilateral like a triangle has to have 180 degrees.
So the interior angles, they add up to 360 degrees, right?
Yeah. It can't be any other way or else it would.
Right. Okay. What if I put a right triangle in a circle? Well, maybe we should start with, what if we put a triangle in a circle? Should we start with that? I've got to make a bunch of copies with papers with circles on them. Okay, let's just put a triangle. Now this time, what is the sum of the three interior angles? 180. And so if you look at angle 1, here's its arc. It intercepts arc AB. We look at angle 2, it intercepts arc AC. And if you look at angle 3, it intercepts arc AC, doesn't it? Is there any overlapping? No, there isn't, is there? They only intersect 360 degrees of arc. And half of that is 180. So there's the sum of the interior. I guess that's another way to prove that the sum of the interior angles of a triangle is 180, isn't it? We've done it other ways, but that one works. Okay, so now, what happens if I put a right triangle? If I put a right triangle inside of a circle, if it's a right triangle, what's the measure of one of its angles for sure? 90 degrees. Okay. So, if that angle is 90 degrees, then how big of an arc does it have to intersect? 180 degrees, right? Okay. Isn't that a semicircle? So, the only way that's possible is if the hypotenuse of the triangle is a diameter. That's the only possible way. So I'm going to show you how to draw a right triangle. I'm going to show you how to draw a really accurate right angle. Start with a circle. Isn't that weird? Let's draw a right angle. Start with a circle. That's odd. Draw a diameter. Put a point anywhere on the circle that you want. Connect it to the ends of the diameter. Wha-bam! Right angle! Want to try that again? Okay, I'll go around the circle. You guys tell me when to stop. Right there? Is that what it was? Right angle. Should we go somewhere else? Like kind of, how about here? Right angle. How about if we go really close, like right there? Right angle. What if we go right dead in the center? Right there. So that this comes, oh wait. If we come off of that with a radius that's perpendicular right there, and we go right from that point. (45, 45, 90) right triangle. So, how do you draw a right angle? Start with a circle. I love circles. They're the bomb. Get it? Bomb. Oh, wait, those are spheres. Okay, so I'll show you the one that is going to make you angry today if I don't talk to you a little bit about it. this the one I want to talk to you about? Yeah, it'll work. Can you guys figure out the measure of x and y?
I'm sure possibly do it.
Okay, so y would be 90.
What it? What's the measure of this arc right there? 136? Okay. And then the measure of that arc right there. 164. You see it? Okay. And this little bit is where we overlap, isn't it? So 164 subtract 136. That's a hard one. You have to borrow. Can you guys do that? Can you guys? Yeah? So this arc right here is 28 degrees. Can you also tell me about this arc over here? $360 subtract 136 subtract, well, 136 goes all the way over to here, doesn't it? And so
We have to subtract 28.
maybe we better label these each individually. 136 subtract the 28. So this bit's 108. Then 164 subtract the 28. This bit over here is 136. So 108 plus 28 plus 136, 272. Subtract 360. So we got 88 over here. So now we know all the little pieces, don't we?
Yeah, so for y.
So can you guys see angle X? It intersects all the way from here, 136 degrees plus the 88 degrees to here. So if you add those two together, divide by 2. Okay. So were we able to find angle X directly? No. But are we able to go around and figure out every little individual arc and angle eventually? It's making sense? Chloe, your eyes don't look like they're just normal today. That's good, right? Feeling okay about this?
Yeah.
Or did this one freak you out?
Yeah.
Yeah, a little bit. I thought it might. The other thing is, as you guys look at a circle, you're going to see problems where two angles intercept the same arc, and you've got to just keep in mind they have to have the same measure. Okay? All right. So here's your assignment. This is chapter 10.4.